Let's go ahead and get started with page 845, number 85. The problem reads as follows. A total of $25,000 is invested in two funds. One pays 6%, one pays 8% interest. One has a lower risk, one has a higher risk. The investor wants a total yearly interest of $2,000. That's what he wants his total interest to be. Write a system of equations. Now, I'm not going to read the rest of this. We obviously are going to solve for how much money is going into both funds, okay? Now, we have two unknowns. We have the 6% interest fund, and we have the 8.5 interest fund. Now, I'm going to use these unknowns. I'm going to use S for 6. I'm going to use E for 8. So there's my two unknowns, S and E. Okay? Now, the total amount of money I'm investing in S plus the total amount of money I'm investing in E should equal 25,000. So there's one equation right there. I have two unknowns, so I need two equations. And by the way, how did I know that? Because it says right here, a total of 25,000 is invested in two funds. Now, I don't know if you put 10,000 in one and 15,000 in another for a total of 25,000. I don't know if you put 5,000 in one and 20,000 in another. I don't know. But I'm about ready to find out, okay? Now, my next equation will be this. My S fund gets multiplied by 6%. Now, when I take my S fund and I multiply it by 6%, that gives me out the interest I made. Plus, the E fund gets multiplied by 8.5%, so 0.085 times E. Okay? So, when I multiply 0.085 times E, that gives me the interest that I gained. So I've got interest here plus interest here. When I add up all of my interest, I should get 2,000 because that's how much interest I want to gain. Now, you are more than welcome to solve this system by using linear combination or substitution, whatever. I'm going to use matrices. So very quickly in my calculator, I'm going to enter in a 2 by 3. A 2 by 3 matrix. And I'm going to put 1, 25,000. You'll become very fast at this if you'll use your matrices a lot. Then 0.06, and then 0.085, and then 2,000. Okay? So after you've entered that into your calculator, then come out of your matrix, then go back into the math segment, enter RREF, and then wherever you put this matrix in, A, B, C, D, or whatever, go ahead and hit that matrix. So you'll have this right here, matrix A, or whatever matrix it was, and then hit enter. And if you do that correctly, you'll get out this matrix right here, 1, 0, 0, 1. And then for the numbers over here, you are going to get, let me check and see here what I get out. You're going to get out 5,000 right here. And you're going to get out 20,000 here. Now the question is, what amount was invested at 6%? Well, think about it, guys. Remember, your S's came first, then your E's. So your 6% came first, so here's your 6%. And here's your 8.5% right here. So how much money did you invest at the 6%? $5,000. That's how much you invest at the 6%. Fund, the 6% fund, you invested $5,000. Okay, hope that makes sense. Moving on, number 87. You are offered two jobs selling dental supplies. One gives you straight commission. The other offers a salary plus commission. Okay, how much would you have to sell in a week in order to make the straight commission offer better? Now, guys, before you start trying trial and error and all kinds of stuff like that, let's just write a couple equations here, okay? You have a salary for one job is what? 0.06 times your sales. We'll call your sales X. And S here stands for your salary, okay? The other job has this salary to offer you. You know you're going to get 350 guaranteed every week. Plus 3% commission, so 0.03 times your sales. Now, students, instead of trying trial and error, look, let's just find out when the salaries would be the same. when the salaries would be the same as your point of equilibrium. In other words, what x value would you put in for x that gives you out the same s? So in other words, to find that out, just simply set the two equations equal. So get rid of your s. S equals this. So I'm going to put this over here for s. And now I'm going to solve for x. Okay, so here we go. Bringing my 0.03x over, I'm left with 350 equals, becomes a negative 0.03x when I bring it over, equals 0.03x. Then grab your calculator and go ahead and type in 350 divided by 0.03, and you will get 11,666.67. Now let me glance at the answer in the back of the book. Yeah, that's correct. So, $11,666.67 is how much your sales has to be in order for, now listen, in order for both of these jobs to pay the same amount. Okay? So, if you make a little more than that, then it would be better. If you know that you can make a little more than this much here, then you know it would be better to take the straight commission offer because you'll make more money, okay? So let's say that you know for sure you can sell $13,000 worth of merchandise or dental supplies. Well then, you'd be better off taking the 6% job because you're going to make more money on that than you would getting 350 and then 3% of this, okay? So do you see how setting the two equations equal helped you find a point of equilibrium? Alright, or in other words, when I say point of equilibrium, I mean a point x that gave you out the same s, okay? So, if you were to substitute this in to the two equations, you would get out the same salary. So if you make more than this, then you want to go with 6% commission salary. So how much would you have to sell in a week? More than this right here. More than this. Okay, moving on to number 89. What are the dimensions of a rectangular tract of land if its perimeter is 40 and its area is 96? Okay, no problem. What are the dimensions? So we're looking for an x and we're looking for a y, or in other words, we're looking for a length and a width. Okay, so we have how many unknowns? 2. So we need two equations. Now if you'll think about it, I have one equation right away. It's so easy. It's W plus L plus W plus L equals 40, right? I mean, if this is W here, this is W over here. If this is L here, this is L. If I take W plus L plus W plus L, that's my perimeter, and my perimeter is 40. So there's one equation. Let's simplify that. We get 2W plus 2L equals 40. And let's simplify it a little further. Let's divide everything by 2. W plus L equals 40, or equals 20. Now the other equation deals with the area. The area of this is 96 square kilometers. So if you take length times width, you will get what? 96. So there's your two equations right there. We could easily solve. Now, you're going to have a hard time using a matrix on this, so please do not use your matrices on this, okay? Because notice you've got a term here that has two unknowns. You're multiplying those together, so you would not want to use RREF on this. Instead, we're going to do it the old-fashioned way. Really, it's not that hard. Just bring the L over and make it a negative L. So W equals what? 20 minus L. Or if you wanted to leave the L here, you can say L equals 20 minus W. Now for the W right here, put 20 minus L. So L times 20 minus L equals 96, okay? Now, L times 20 would be 20L minus L squared equals 96, okay? Now, we want to get one side equal to 0 because we have a quadratic equation. We might be able to factor it, so negative L squared plus 20L. So I wrote this term first and this term second, no big deal. And then I'm going to bring the 96 96 over and make it a negative 96 equals 0. Now, whenever you're trying to factor, hardly ever do you want your first term negative. So let's go through and change all the signs. L squared minus 20L plus 96 equals 0. Okay, there we go. Now, students, we're looking for two numbers that when multiplied together give us 96. When added together give us 20. Well, that were negative 20. Well, that would be a negative 8 and negative 12. If you add those two, you get negative 20. If you multiply those, you get a positive 96. So, my factorization would be L minus 8, L minus 12. Okay? Alright, now let's get some more space up here. So, if you take this parentheses here and set it equal to 0, L equals 8. If you take this parentheses here and set it equal to 0, L equals 12, okay? So to be honest with you, you can call the length and the width whatever you want, okay? It doesn't matter. If you say one of them's 8, we'll say 12. The length is 12. Then what's over here? 12. Well, then what has to be here? 8, because the area is 8. 12 times 8 is 96, and you put an 8 here. Okay? So there's your dimensions. Or if you want to put an 8 here, and a 12 here, and a 12 here, and an 8 here, it really doesn't matter. Either way, the dimensions are 12 by 8. 12 kilometers by 8 kilometers. There's your answer. Okay? Alright, so there's the dimensions. Alright, moving on. Oh, and by the way, if you add all these together, you would get 40 for the perimeter. Okay, so it does work. Alright, number 91. An airplane is flying into a headwind that travels the 1,800-mile trip between two cities in 3 hours and 36 minutes. On the return flight, the distance is traveled in 3 hours. Find the speed of the plane, the speed of the wind. So here we go. Speed of airplane. We're going to denote that by the variable A. And the speed of the wind, we're going to denote that by W. So there's my two unknowns. Now if I have two unknowns, I probably need two equations. Remember, we're dealing with rate times time equals distance. Okay? Or in other words, I like to use speed for rate. So speed times time equals distance. Okay? There we go. So here we go. One equation is this. I have the speed of the airplane minus the speed of the wind, because the wind is slowing it down. So there's your speed times your time. My time is, well, when it went slower, it was 3 hours and 36 minutes. Now 36 minutes would be the same thing as 36 over 60. Okay? And if you reduce that, you're going to get 3/5. So you really have, your time is 3 3/5. Okay? Or in other words, to make this a little easier, 3.6. And of course the distance was 1,800. Now on the way back, the wind was pushing the airplane, so you have the speed of the airplane plus the wind. That's your speed, okay? Times your time, and your time was just 3 hours, and the distance was the same. So I can use my calculator, make some, and use matrices and my RREF button, and really solve this pretty quickly, okay, like this. Let's simplify. I have 3.6a plus, or not plus, sorry, minus 3.6w equals 1,800. Then here multiply your 3 through, we have 3a plus 3w equals 1,800. So go ahead and type this into your calculator very quickly. Go to your matrix button. You're going to enter a 2 by 3, and it should look like this. 3.6, negative 3.6, 1,800. You can enter that very quickly. And then 3, 1,800. Okay? And then go to your RREF button and do RR reduced row echelon form to this matrix right here. And if you do that correctly, you will get out this right here. You will get out a matrix with a 1 here, a 0 here, a 0 here, a 1 here, Uses two different machines working continuously to produce deodorant containers. One machine produces the containers 1.8 times faster than the second machine. If there are 1764 containers, how many are produced by each machine? So we have, I'm going to call it machine X and machine Y. So there's your unknowns, okay? Machine X, of course, is denoted by X, and machine Y is denoted by Y. Now, I have no idea how many out of these total containers are made or produced by machine X or machine Y, but I know this. If I add the two together, I know the total produced is 1,764. Okay? Now, notice this sentence right here, guys. Let me get rid of this red circle here. Notice this sentence right here. Well, I give up. One machine produces the containers 1.0 times faster than the other machine. So it really doesn't matter which machine you say is faster than the other. I'm just going to say this. X equals 1.8y. So X is faster, okay? If you take the Y amount, the Y machine amount, and multiply it by 1.8, that's how much X does. Now, students, you are more than welcome to write it this way. Now, usually in a problem, it does matter. It does matter how you write this, but up here, it doesn't tell us which machine is 1.8 times faster than the other machine. So we can write it either way because it never says which one. Now, I am going to use matrices, so I'll tell you what, you know what? I think it'd be faster to not use matrices in this problem. Here's my one equation, here's my other. What does X equal? 1.8y. So what are you going to put for X up here? 1.8y. So 1.8y plus y. This is the substitution method. Whenever you have two unknowns, two unknown systems, you can use substitution. And now watch how quick this is. 2.8y equals 1764 because 1.8 plus 1 is 2.8. Now I'm going to grab my calculator. 1764 divided by 2.8 is going to give me 630. So, machine Y produces 630. Now, machine X produces 1.8 times that. So I'm going to take 630 times 1.8, and I'm going to get 1,134 for machine X. Now, I've not added these two together, but if you add these two together, you should get 1,764, okay? So that's how you would solve that. And moving on to problem number 95, okay? This is a pretty tough problem, so please listen carefully. I'm not going to really listen to what they're telling me to do here. I want you guys to learn to set these up on your own without looking at that, okay? Alright. 10 liters of a 30% acid solution is obtained by mixing 20% and a 50% solution. So you have two solutions. One is weaker than the other. One's 20%, one's 50. You want to mix those guys so when you're all done you have 10 liters. And those 10 liters are a 30% acidic solution. So you gotta be careful how you're gonna do this, okay? So I've got two unknowns. I'm not going to get another page up here. I have two unknowns, okay? I've got my liters of my what solution? 20%. And I've got my liters of my what solution? 50%. Got it? And I'm gonna pour all of that into a big container. Got it? And I want my big container to be what? Let's go back. I forget. Let's go back and look. I want to have 10 liters. That's 30% acid. So I'm going to pour some 20% in, some 50% in when I'm all done. And this right here is my X liters. Got it? I don't know how many liters I'm putting in, so I'm going to call it X. I have no idea how many liters this is, so I'm going to call this Y liters. Now when I'm all done pouring in my X and Y, I'm going to end up with how many liters? 10. And what percentage of acid will it be? 30%. So I have two unknowns. How many liters of this solution and how many liters of this solution am I going to put in? So I need two equations. Well, guys, the first one is simple. Come on. X plus Y equals equals 10 because I'm not sure how many liters I'm going to pour in, and I'm not sure how many liters I'm going to pour into the solution, but I know when I'm all done, I'm going to have a total of how many liters? 10. So there's one equation there. Now the other one's a little trickier, okay? I'm going to take my total liters x and multiply it by 20. That gives me just my acid. Okay, think about it. 20% times your total liters gives you how many liters of acid you have. Plus, I'm going to take 50% times my y. Now when I take my total liters y and multiply by 50%, this gives me my total amount of acid only. So I'm really taking acid plus acid here. Okay, think about it. I know that I don't know how many liters of X I'm putting in, but however many liters it is, if I multiply it by 20, that gives my acid to me. I have no idea how many liters of Y I'm putting in, but if I multiply my total liters of Y times 0.50, it gives my acid to me. So I have acid plus acid should equal my total acid. Now what's my total acid? Well, how many liters do you have? 10. At what percentage of acid? 30%. So if you take your total times the percentage, this will give you the acid also. So I have acid plus acid equals my total acid, which is totally a true statement or a true equation, okay? So now I have my two equations up here, alright? So it's up to you really, students. I think I'll go ahead and use matrices on these very quickly. I'm going to go ahead and multiply 10 times 0.3 to get a number over here. And if you do that correctly, you will get 3. So really this whole side over here, 10 times 0.3 is just 3. So now very quick, you can do this so quickly. Go to your matrix, type in a 2 by 3, put 1, 1, 10, put 0.2, 0.5, 3, and then go to RREF and do RREF to this matrix here. And if you do that correctly, you're going to come up with this matrix right here. You have a 1 here, a 0 here, a 0 here, a 1 here. And for the 20%, which is your X, you're going to have 6 2/3, or 6.6 repeating. And for your other liters for mixture Y, you're going to have 3 1/3, or 3.3 repeating. Okay, so there's the amount of liters. So we're going to pour 6 2/3 liters of the X in. We're going to pour in 1 or 3 1/3 Y liters in, and we will get out 10 liters, and we'll get out a 30% acidic substance. Now let's come over here and see, using a graphing utility to graph the two equations in part. As the amount of 20% solution increases, how does the amount of percent change? I mean, guys, I'm not going to take time and do that. It really is common sense. Think about it. My goodness, guys. As the amount of the 20% solution increases, how does the amount of the 50% solution change? Well, guys, think about it. You want to get out a 30% solution, right? So if you have 50% going in, are you not going to have to pour in more 20% solution to lower the 50% down to a 30? Of course, if you put in more 50 than 20, then you're going to have a pretty high solution, okay? So, as the amount of the 20% solution increases, how does the amount of the 50% solution change? It decreases. As this increases, this decreases, okay? And then how much of each solution is required to obtain the concentration? Well, we got it right here. We already found it. Right here. 6 2/3 of the X of the 20% solution, and 3 1/3. That should be a 3. 3 1/3 of the 50% solution. Okay, moving on to a new page, and it's page number 855, numbers 55 through 65. And here we go. The University of Miami and Florida State scored a total of 30 points during the Orange Bowl 2004. The points came from a total of 9 different scoring plays, which were a combination of touchdowns, extra points, and field goals. How many touchdowns, extra points, and field goals were scored? So right off the bat, I have 3 unknowns. Now it's pretty obvious what my unknowns are going to be. I'm going to use T for touchdowns, E for extra points, and F for field goals, okay? So let's think this through for a second, guys. I don't know how many total touchdowns there were. Yet, I don't know how many extra points there were, and I do not know how many field goals there were, okay? But I know this. If I add them all up, I should get 9. Where'd you get 9, Mr. Earhart? Because right here, the points came from a total of 9 different scoring plays. So hopefully you understand. I don't know if it's 6, 3, and 3 or whatever. I don't know. That wouldn't be 9, would it? That was funny. But I'm not sure what I'm going to have. I know it's going to add up to 9. So I have 3 unknowns. I need 3 equations. Let's see what else I can figure out here. Oh, they scored a total of how many points? 30. So if I take every touchdown and multiply it by 6, take every extra point and multiply it by 1, and take every field goal and multiply it by 3, I'm going to get a total of how many points? 30. Now look at this. We need one more equation, right? Look at this. The same number of extra points and touchdowns were scored. Well, that's obvious. You can't have an extra point unless you have a touchdown. Actually, it's not obvious. I'm wrong. You could not assume that because you could have had a touchdown in which they missed an extra point. So you could have had 4 touchdowns. Sorry for yawning, and only 3 extra points. But anyways, they tell us here in this case that there were the same number of extra points and touchdowns were scored. So that means touchdowns equaled extra points. T equals, that's another equation. Now, because we're going to use our matrices, I want my E over here. So I'm going to subtract the E, and I end up with T minus E equals 0. Okay, so let's go ahead and get rid of this right here. And let's bring this over to here. And now I would encourage you to real quick whip out your calculators and go right to the matrix part. And I would type this in. I would go 1, 1, 1, 9. Next, students, I would have a 6, a 1, a 3, and a 30. Now be careful for your last line here. I have a T, 1 T, so I'll put a 1. For E, I have a negative 1. Notice there's no F, so I put a 0 for F, and then a 0 here. Now students, if you enter that matrix there into your calculator, and then use your RREF button, you will get this matrix out right here. If you don't, you're making a mistake somewhere. And then over here, your 3 numbers will be 3, 3, and 3. There were 3 touchdowns, 3 extra points, and 3 field goals, okay? And that would give you a total of 30 points, by the way, okay? So there's your answer right there. Okay, pretty cool problem. Moving on to number 57. A small corporation borrowed this much money. They did not borrow the money from the same place. They borrowed some at 8%, some at 9%, and some at 10%. How much was borrowed at each rate if the annual interest rate owed was this much and the amount borrowed at 8% was 4 times the amount at 10%? Okay, we have 3 unknowns. The amount borrowed here, the amount borrowed here, and the amount borrowed here. Got it? 3 unknowns. So I need 3 equations. Now I'm going to use an E for the amount borrowed at 8%, an N for the amount borrowed at 9%, and a T for the amount borrowed at 10%. Now I have no idea how much I borrowed at the 8%. And I have no idea how much I borrowed at 9%, and I have no idea how much I borrowed at 10%. However, if I add them all together, I know the total amount I borrowed was $775,000. So there's one equation. Now, if I take the amount I borrowed at E and multiply it by 0.08, that gives me my interest right here for the 8%. And then for my 9%, if I multiply my amount times 0.09, that gives me the interest here. And then plus, if I multiply my amount at 10% by 0.10, that gives me the interest here. So I have interest plus interest plus interest would give me total interest, okay? So my total interest, if you'll look at the problem, they tell me the total interest owed was $67,500. So my total interest will be $67,500. And now you're seeing, when you start doing really big numbers like this or decimals, it's so nice to use the RREF button. Now, listen guys, just read the sentence as it reads. 8% is what? E was was means equals or is. 8% is 4 times the 10%. So 4 times the 10%. There it is. Is that easy? The amount borrowed at the 8% is equals 4 times the amount borrowed at the 10% T. So there it is, okay? Now that's my other equation, but really, guys, you understand I want it to be written a little differently. I'm going to bring the 4T over and make it negative. So E minus 4T equals 0. There. Now I've got my three equations. Very quickly with a matrix, I would, first of all, get rid of this thing. Oh, what are they asking us? How much was borrowed at each rate? Okay, now, get a little room up here. Okay, very quickly, you can enter this into your calculator. This is 3 by 4. So you enter 3 by 4, and I would just go 775,000. And then 0.08, 0.09, 0.1 is the same thing as 0.10, and then 67,500. And be careful, here's your E, so put a 1 here. Then there's no N, so put a 0. This is your E column, this is your N column, this is your T column, okay? So for your N column here, I'd put a 0. And then for your T column, it's a -4. Watch your signs. And then a 0. If you enter all this into your calculator correctly, okay, and you then hit enter on your if you then go to RREF and you use RREF on this matrix right here, you will get out this matrix right here. You will get out a 1, a 0, a 0, a 0, a 1, a 0, and a 0, 0, and a 1. And then for these numbers right here, you're going to have, let's see, what would you get? You would get 300,000, 400,000, and then 75,000. Okay, now this would be at your 8%, this would be at your 9%, and this would be at your 10%. So there we go. We found the amount that was invested at each percentage. All right, let's try number 59. The certificates of deposit pay 10% annually, and the municipal bonds pay 8% annually. Over a 5-year period, the investor expects the blue chip stocks to return 12% annually, and the blue stocks and the growth stocks to return 13% annually. The investor wants a combined annual return of 10,000 and also wants to have only 1/4 of the portfolio invested in stocks. Now, let me turn back in my book. We need the directions for this problem. And hold on one second. I have my book marked on the answer page where I've been checking our answers to make sure that we're getting them right. So 855 is where we're at. Okay, the directions say there's an investor with a portfolio totaling 500,000. So in other words, if you look at the direction, this guy wants to invest. His total investment is going to be 500,000. Okay, there we go. Now, so that's all we need to know from the directions. Now, we're looking for the directions say how much is invested in each type. Well, let's see how many we have. We have certificates of deposit, municipal bonds, blue chip stocks, and growth stocks. So we have 4 unknowns. 4, okay? We have, let's see, we can use C for certificates, M for municipal, B for blue chip, and G for growth. Okay, so there's my 4 unknowns. So I need 4 equations. Well, I'm not sure how much I'm investing in each one, but I know if I add up each one, how much I'm investing here, how much I'm investing here, how much I'm investing here, and how much I'm investing here, it'll equal 500,000 because it said in the directions that's how much money I had to invest. Okay, now let's continue on. Let's see if we can come some more equations here. The certificates will pay 10%. wants to pay 8%. Now, don't be confused by this phrase here. It says over a 5-year period, the investor expects the blue chip stocks to return this 12% annually. That means every year for 5 years. And the growth stocks to return 13% annually. So they just threw this in here to confuse you, okay? Over a 5-year period, the blue chips will go at 12% annually, and the growth stocks will return 13% annually. So don't worry about the 5-year, it doesn't do anything, doesn't matter. So the blue chips are going to gain 12% annually, and the growth are going to get 13%. Now, what's the total amount of money? Well, look right here. Look, guys, the investor wants a combined annual return of 10%. Okay, let's go that again. The investor wants a combined annual return of 10%. So this is interest he gained, this is interest he gained, this is interest, this is interest. You're adding interest plus interest plus interest plus interest. And the total interest you're going to get is 50,000. Whoa, where'd you get 50,000, Mr. Hart? Well, it says 10%. He wants an annual return of 10%. So he invested 500,000, okay? And he wants to get back 10% of that on top of that, so 50,000, that's his interest. Now, he also wants to have only 1/4 of the portfolio invested in stocks. So if I take, now watch this, if I take these aren't stocks, this is a bond, and this is a certificate of deposit. I don't know what that is, but it's not a bond, it's not stock, excuse me. And municipal is a bond. So these two here are not stocks, okay? Understand that. Now, these two here are stocks. Blue chip stocks, growth stocks. So if I take all of my stocks that are blue chip and all of my stocks that are growth and add them together, I want it to be 1/4 of the portfolio. So my portfolio is 5,000, correct? Or 500,000. So I'm going to take 500,000 and divide it by 1/4. And I just messed that up. Let's try that again. And that's going to be 125,000. So when you add these two together, you get 125,000. Now, listen to me, students. Listen. There's not another equation you can come up with. So we only have 3. So what does that tell you? That tells you your answer is going to be infinite solutions or more than one solution. In other words, you can't solve this. You cannot tell me how much he's going to invest in each one. You can't do it. But we can still remember when we have infinite solutions, we can write our answer based on Z, and we put an A in for Z and all that kind of stuff. Well, that's what we're going to do here. We cannot really get an exact numerical answer, so here's what we're going to do. We're going to very quickly enter this into our calculator as a matrix, okay? So real quick, here we go. We're going to have a 1, 1, 1, 1, and then 500,000. And then a 0.1, and a 0.08, and a 0.12, and a 0.13, and then 50,000. And then 0, and then 0, and then 1, and then 1, and then 125,000. Now, go ahead and enter your calculator, and when you're done, then go ahead and do RREF, and you should come up with this matrix right here. Go ahead and do that quickly. Pause the video if you need to, and then when you're done, you should get this matrix here. And actually, before I write that matrix, I'm going to go ahead and slide this out of the way. You should get this matrix right here. If you did it correctly, you're going to get 1, 0, 0, 0.5, 250, and I've got to look at my calculator. Hold on 1 second. 250,000, and then you'll have 125,000 here. And by the way, you can scroll to the right and scroll to the left and look at the matrix if you need to, okay? And then you would have 0, 1, 0, negative 0.5, and then 0, 0, 1, 1. Okay, now, that's what you should get out in your calculator, okay? So let's take a look at that. You say, well, Mr. Eric, then the answers are right here. No. First of all, you have to have 1, 1, 1, 0, so you have to have 0 here, 0 here, and all that stuff. Okay, what we have is this. Remember, we started off with, I should have erased what I just erased. Hold on a second. Let me get this back up here. Okay, so our first equation, we have C, M, B, and G. Okay, so this top equation here is 1C plus 0.5G. Remember, this is your C, this is your M, this is your B, this is your G. Certificate of deposits, municipal bonds, blue chip stocks, growth stocks. So 1C plus 0.5G equals 250,000. There's one equation, okay? The other equation is 1M minus 0.5G. 1M minus 0.5G equals 125,000. And then 1B plus 1G equals 125,000. Now that's what it tells us. So here's what we're going to do. It really doesn't matter where you choose A and B and all that. I'm going to let, let's put slide up here. Remember, I have 4 unknowns. Please don't lose sight of that. Looking for the amount in the certificate of deposits, looking for the amount in my municipal bonds, looking for the amount that I invested in my blue chips, and looking for the amount I invested in my growth stocks. Now, I'm going to go ahead and let A equal G. So if A equals G, I'm going to put A in for G like we've done before, then B would equal 125,000 minus A. Remember, for G, I'm going to put an A. Bring the A over and make it negative, and B equals this. Now, I'm going to come up here to my next equation right here, okay? For G, what am I going to put? A. So I have 1M minus 0.5A equals 125,000. Now, bring this over and make it a positive 0.5A, and you're left with 1M. Well, 1M is the same thing as just M. So now you know what M equals. M equals 125,000 plus 0.5A. And then lastly, we're going to find out what C equals. Notice I have a G again, and G is A, so I'm going to put an A right here, okay? So 1C, or just C, equals 250,000 minus 0.5A. So that's going to go right down here. And that's what C equals, okay? And so there we go. Now, Mr. Earhart, those aren't real numbers, I know, but you can tell me now, out of your 500,000 you want to invest, and boy, it'd be a lot of fun to have that kind of money to invest, wouldn't it? But anyways, out of that 500,000, whatever you pick, like let's say you pick 200,000 to go into your growth stock. Well, no, you couldn't do that because the most was 1/4. Let's say you picked 100,000 for your A. Now you know what everything else has to be. Put 100,000 here, so you're left with 25,000. Put 100,000 here times 0.5, subtract that from 125, etc., etc. So as soon as you know what G is, then you can find out what everything else is. And that's this. There's really no way to know the exact amount because they didn't give us enough information. However, what we can do is come up with variable answers like this, and that's a really big help. Okay, all right, moving on to number. I want to say one more thing. The reason I knew that my answer was not going to be numerical, don't forget, is I had how many unknown students? 4. And how many equations did I have? 3. So I knew there was no way I could get out a real number answer. It was going to have to be infinite solutions, which would then mean I could write my answer in terms of A. All right, moving on. I think the back of the book used S instead of A, which is their business. Okay, I just chose A. No big deal. All right, number 61. This is a really tough problem, so please pay attention. All right, here we go. A mixture of, let me slide my book forward here to the answers in the back of the book, so I have those ready. Hold on one second here. I'm going to check that last answer. Yes, we got the last answer correct. Okay, number 61. Now, here's what your goal is. You want to have a mixture of 12 liters. So in the end, you want to have 12 liters. Got it? That's your goal. You want to have 12 liters. And you want, no, I apologize. You want to have So spray X has, now watch, 1, 2, 2. So it's 1/5 chemical A. Do you see that? 1 out of 5. 2/5 chemical B. 2 out of 5. And 2 parts chemical C. So 2/5 C. Got it? So there's spray X. So if you buy spray X, it's going to be 1/5 A, 2/5 B, and 2/5 C. Okay? If you buy commercial spray Y, it contains only chemical C, only. So I'm going to put a 0 for the A, 0 for the B. I'm going to put 1 for the C. It's not 1 liter, just 1 unit. It's 1 whole amount of all C. Now, spray Z has only A and B in equal amounts. Equal amounts. So it's 1/2 A and it's 1/2 B. Half and half. C is 0. Now, how much of each type of commercial spray is needed to get the desired mixture? How much of each commercial spray is needed? Okay, so we're going to get rid of this. We know what we're looking for now. We want to know how much of each commercial spray is needed. Alright, and so we have 3 unknowns. How much of my X, how much of my Y, and how much of my Z. So with that in mind, I have 3 unknowns. I know I need 3 equations. Hopefully I can come up with this. It's not going to be easy. Now, let's deal with chemical A. First of all, I know I want 12 liters, okay? I want a total of 12 liters. So, I'm going to say this. I'm going to say I have 1/5 times my X, okay, that's for my A, plus 0 for my Y, plus 1/2 times my A, times my Z, and that would equal, hopefully, 12 liters, okay? Let's stop and think that through. Here we go. X is my amount of liters, Y is my amount of liters, and Z is my amount of liters. So I'm taking 1/5 of it, 0 of it, 1/2 of it, and when that's all added up, I'll have 12 liters coming out of getting chemical A out of all 3. Now, let's talk about chemical B, okay? From spray X, I know I have 2/5 X. I have 0 of chemical B in my Y spray. And I know I have half of the spray from Z is going to be chemical B. So all my total chemicals from B would be 16. Okay? Now that's true so far. That's good. Now here's another one, okay? I could also say that, let's see, 2/5 of spray X is C. Okay? So there's my C. This is my chemical A equation. This is my chemical B equation. This is my chemical C equation. So 2/5 X gives me my C, plus 1Y gives me my C. Okay? And then over here I have 0. And that gives me a total of chemical C, which is 26. So there we go. So there is my equation, hopefully. Alright, now, because I have all these fractions and all this, I'm going to use matrices. And so I'm going to very quickly type this into my calculator like this. And I'll have 1/5, going really fast, 1/5, 0, 1/2, 12, 2/5, 0, 1/2, 16, 2/5, 1, 0, 26. Alright, so quickly type that into your calculator and then do the RREF button. Now, if you've done all that correctly and you've typed it into your calculator correctly and used your RREF button, you will get out this matrix right here. You'll have a 1, 0, 0, a 0, 1, 0, 0, 0, 1, and then going down you'll have 20, 18, 16. So this would be, this is how many liters of your spray X. Spray X. 18 would be your liters of spray Y, and 16 would be your liters of spray Z. And by the way, if you add these up, what do you get? 54. If you look back in your notes, at the start of this problem, I told you we needed 54 total liters. Okay? So that's how many liters of one type, and another type you would mix into one big container to get the proper spray that you want. Okay, moving on to number 60. This is really a weird problem. It's really easy, unless I'm misunderstanding what they're saying. And I think it's kind of a joke, but we'll do it very quickly. Then we have one more to go after that, which is, this is a really tough problem here, and then we're finished. Okay, so here we go. A small company that manufactures 2 models of exercise machines has an order for 15 units of the standard model and 16 units of the deluxe model. The company has trucks of 3 different sizes, as shown in the table. Alright, now I think I cut part of the problem off, which I did not, of course, mean to do. Let me turn quickly to page 855. I think it just says to give different types of scenarios of how many trucks, of what trucks you would need, how many trucks of each size are needed to deliver the order. Give 2 possible solutions. Well, guys, let's just deal with all large trucks, okay? I mean, in a large truck, you get 6 standard and 3 deluxe. So, let's see if we take 6 trucks, so 6 large trucks should do it. So there's one scenario. 6 large trucks would do it, right? Because that would give me enough room for 36 standard, that's plenty, and 18 deluxe, that's fine. Let's work with the medium trucks, okay? Let's say for medium, I would want, probably 5 medium trucks would work. And by the way, you could also mix and match if you wanted to. You could have so many large and so many medium. I'm just going with one type. 5 mediums should do it, because 5 mediums, 5 times 4 would give me 20, space for 20 standard. I only need 15. And actually, we could do 4 mediums, because 4 times 4 is 16, and 4 times 4 is 16. So one scenario takes 6 large trucks. Another scenario is take 4 medium trucks, okay? So and you could also mix and match, but that's good enough. They asked for 2 scenarios. Okay, last problem we're finally done. This is a doozy, okay? A chemist needs 10 liters of a 25% solution, acidic solution. Let's write that down. That's what he needs. 10 liters at 25% acid, okay? The solution is to be mixed from 3 solutions whose concentrations are 10%, 20, and 50. How many liters of each solution should the chemist use to satisfy the following? Okay, you want to use as little as possible of the 50% solution. Now, please listen carefully to me, okay? If you have 10%, 20%, and 50% solutions you can use, and you want to use the smallest amount of 50, that means you want to use the most you possibly can from over here. Now, there's no way you want to use 10%. Listen to me, I'll tell you why. If you used, think about it, let's say I took 1 liter of this and 1 liter of this. That would give me a concentration a little weaker than 20%, okay? However, instead of 1 and 1, if I took 2 liters from here, that would give me a stronger solution, a 20% solution. So if I use all 20%, if I use no 10%, and I use as much 20% as possible, that will give me the least amount of 50% possible. So here's what I'm going to do. Okay, watch this carefully. I'm going to say this. I'm going to say that I'm going to take how many liters of the 20%? I have no idea. I really don't know. So I'm going to say 0.2 times X. Okay? Plus, now, how much of the 50% am I going to take? I don't know, but I know this. Whatever I put in here is going to be 10 minus that. Now, that's tough to see, but it's the truth, guys. Look, I want a total of how many liters? 10. So, however many liters I put in here, let's say I take 8. Then over here it's going to be 10 minus 8 is 2. This is really hard to see. That's how you would do that. So, after you take your 20% times this, that's your acid. Take your 50% times this acid. You have acid plus acid. So, how much acid do you have over here? Well, 0.25 times what? 10. Let's solve this very quickly, okay? 0.2x plus 5 minus 5x equals 2.5. Now, we can simplify your x terms over there. And that would give us, let's see, 0.2 minus 5 is going to give me a negative 4.8x. 5 minus 0.2, and then bring your 5 over and make it a negative 5. That leaves you at negative 2.5. So I'm going to take negative 2.5 divided by negative 4.8, and I'm going to get, let's see here, I don't think that's correct. Hold on one second. Guys, I'm sorry, I'm back. I found my mistake. 0.5 times x is 0.5x. Sorry about that. So right here, instead of having negative 4.8 right here, sorry about that, guys, you would have 0.5 minus 0.5, 0.2 would be minus 0.3. Okay? And so that's going to give you, let me quickly divide that out. You're going to get negative 2.5 divided by negative 0.3, which will give you 8 1/3, okay? 8 1/3. So think about it, guys. X is your 20%, right? So if you're getting 8 1/3 for this, then over here you need 1 2/3, because these two numbers together have to add up to 10. Okay? Hope that makes sense. Let's go on now to part 2, okay? Or part B. So here we go, part B. Now part B reads as follows. So here we go. Part B says, you want to use as much as possible of the 50, as much as possible. So students, think about it. If you want to use as much as possible of the 50, then don't use any 10%, okay? Don't use 20%. You want to use the weaker amount so that whatever you're left over with all goes to the 50%, okay? So watch what I'm going to do. Here we go again. I'm going to say my 10% times x liters plus my 50% times now here it is, 10 minus x is going to give me, this is all acid, my total liters here times 0.10 is acid, my total liters here times my 50% is acid. I have acid plus acid equals total acid, which is 0.25 times 10. That's total acid. So here we go. 0.10 times x is 0.1x. 0.5 times 10 would be 5. And then 0.5 times x is negative 0.5x equals 0.25 times 10 is 2.5. Now, combine your x's, negative 0.4x. Bring your 5 over, make it negative. You get negative 2.5, okay? So I'm going to take 2.5 and divide it by 0.4. And you're going to get 6.25. 6.25 or 6 1/4. So x is your 10%. So you get 6 1/4 here. So over here you're going to get 3 3/4 because 6 1/4 plus 3 3/4 gives you a total of 10. Okay. Now almost done, guys. Okay. Almost done. Lastly, we are going to use exactly 2 liters of the 50%. Okay. 2 liters of the 50%. So here we go. Let's go ahead and put 10% here. We'll put 20% here, and we'll put 50% here. Alright, so we're going to use 2 liters exactly of the 50% solution. So, see if this makes sense. My 50%, I'm going to get another page open here. We need a little more room for this problem. Well, we'll just do this. We'll slide that up. And we'll slide that up. There we go. Now, students, watch carefully. I'm going to use 2 liters of 50%, so 0.5 times 2 liters, okay? That leaves me 8 liters. Because the total's 10, I use 2 liters here. So I'm going to take 0.1 times x. I'm not sure how many liters that'll be. Plus 0.2 times what? Not 10 minus x, but 8 minus x. Because I use 2 liters here at the 50%. So these two here have to be a total of 8 liters. So I'm not sure how many liters here I'm going to use, but whatever I use over here is 8 minus my x right here for my liters. So I'm taking percentage times liters, percentage times liters, percentage times, this is all acid plus acid plus acid equals 25% acid times 10. Let's quickly solve this. 0.1 times x plus 1.6 minus 0.2x, because 0.2 times 8, 1.6, 0.2 times negative x is negative 0.2x, and then here I would have plus 1, because 0.5 times 2 is 1 equals 2.5. Now let's get our x's together. 0.1 negative 0.1x equals, here we have 1.6 plus 1, that's 2.6. Bring your 2.6 over, make it negative, and that's going to leave you with a negative 0.1, okay? Which should give you x equals 1, okay? If you take 0.1 divided by 0.1, you will get 1, okay? So, look what my x is, guys. My x is my 10% right here. So, for 50%, I used how many liters? 2. For 10%, I'm using how many liters? 1. So for 20%, it must be how many liters? 7, because 1 plus 7 plus 2 equals 10. This was definitely a challenging word problem, but it's good for you guys. I hope this homework help video has been a help to you guys. If you have any questions, don't hesitate to call or email if you have any questions.